Assalamualaikum and hi. Today my friends and I will present about related rate. But before that, let we introduce ourselves first.
Assalamualaikum. My name is NABILAH binti AHMAD MAZHAR. My student ID is 2020818654 and I am from P2PH1102D1.
Assalamualaikum. My name is TIHANI Sofia binti Mohamed Kamil. My ID number is 2020874932 and I am from D2.
Assalamualaikum and hi everyone. My name is KHADIJAH binti MANJA. My student ID is 2020855626 and I am from class D1. So, what is related rate? Related rate problems involve two or more variables that change at the same time that we assume as t, possibly at different rates. If we know how fast the variables are related and how fast one of them is changing, we can find out how fast the other is changing. This generally involves writing an equation that relates the two variables and deriving the equation with respect to time. In this method, chain rule becomes important for the correct resolution of these problems. Implicit differentiation is often used. So the next is application of differentiation. What is differentiation? It is a process of finding a function that outputs the rate of change of one variable to another variable. We use differentiation to determine whether the function is increasing or decreasing. We can know that the function is increasing because the derivative is always positive. Subsequently, if the function is decreasing, the derivative is always negative. Apart from that, we also use derivatives in our real life, such as profit and loss in business, speed or distance, cost, or amounts of material used in a building, and etc.
Next section is we must to identify the problem statement. So first we must to read the question carefully. A crane is pulled a brick on a ground with a cable that is attached to a pulley. The pulley is hanging at 10 meter above the ground. Highlight 10 meter above, which is the keywords. If the cable is pulled through the pulley at a rate of 20 meter over mean. Highlight rate of 20 meter over mean. At what rate will the brick be approaching the crane when 1 to 5 meter of rope is out? Highlight 1 to 5 meter. Give your answer in radicals. Okay. If we do not understand clearly, we cannot to imagine the structure. We can draw a triangle to represent the crane and the brick, the condition. So this look at the triangle. We can just fill the data from the question at the picture, at the triangle. So we can know that x is unknown and the LDT negative 20 meter over mean. So don't forget to put negative because it's pulled. The cable is pulled through. So this it will be negative direction. So must to put negative on 20. So in the question 1, dx dt. So we must find dx dt, and of course the answer must be in radicals. Okay, let's move to the objective of the question. Okay, first, what things to solve? Okay, from the question, we must to know the condition. What's the question 1? So the distance of the brick from the crane at the ground. So which equivalent to dx dt. And the second thing is main objective. It's because we must to better it's the question state and improvise us, especially student, to be better understanding about the related rates or rate change problems involving geometry formula. And the last one is creative thinking. So the student would be able to apply the chain rule method or implicit method to solve the question.
There are 4 steps to solve the problem. The first step is we can draw the shape and label the quantities. The second step is to differentiate the formula. The third step is substitute with the stated values, and the last step is to solve the dx over dt. The first step is we have to draw the diagram and label the quantity given. The second step is find an equation that relates to the quantity. For this case, we need to use theorem Pythagoras. We know that the L is the hypotenuse, so the equation is L squared equal to h squared plus x squared. Based on the information given, we know that the height is 10 and we have to substitute h with 10. And then we will get L equal to square root x squared plus 100. So we differentiate the formula with respect to the x. That goes for x squared plus 100 to the power of the half. And then we take the derivative by bringing the 1 over 2 in the front and keep the inside of the brackets. And then subtract the exponent down by 1, and then in addition multiply by the derivative of what is on the inside of the brackets. So now the last step is to multiply the half in the front with 2x. And lastly, the answer we will get is x over square root x squared plus 100. Next, before we substitute the value given, we have to find the x in order to find dx over dt. So we know that L is 125 and we have to use the theorem equation to find x. And we will get x equal to 15 square root 69. After the first and the second steps, we have a lot of information now. We have dl over dt equal to negative 20. We have dl over dx equal to x over square root x squared plus 100. We have x equal to 15 square root 69. So now, how do we get dx over dt? We can get it using chain rule, dx over dt equal to dl over dt multiplied by dx over dl. dl over dt is negative 20 and dx over dl is square root x squared plus 100 per x. We cannot use x per square root x squared plus 100 because now we have to change the position into dx over dl, so we have to use square root x squared plus 100 per x. Now, the third step is we need to substitute the stated value by 15 square root 69 and get the last answer negative 2500 over 15 square root 69, which is in radical. So this means when the rope out is 125 meter, the brick will approach the crane at a rate of negative 2500 over 15 square root 69 minute. In conclusion to that, the application of differentiation is used to compute the rate of change using geometry formula. We can accurately count the difference in changes that happen by applying the chain rule method or implicit method to solve the question.